Hey folks, Happy New Year. Today I want to talk about something a little bit different than just diving in and coding a certain language or something on the fly. I think I kind of give the wrong impression when I just jump in and show you, like, hey, I'm just going to code this off the cuff, or, I've never done this before, let's just see how this goes. That impression that I give is really the fact that I've been coding since I was in high school, sophomore year of college, or, I'm sorry, sophomore year of high school. And so they say, 10,000 hours, you become an expert. Like I've definitely been programming for way longer than that. So something like coding is something that comes very natural to me. I used to program on the TI-83. I went to grad school at Georgia Tech from 2009 to 2014. And right before I graduated, you can see here, April 1st, 2014, I started making these real-time simulations back then with OpenGL in the background. And then I moved to Blender. And so this video here is from April 1st, 2014, and it shows my PhD thesis, which is two aircraft that are coming together and linking together. And the simulation that I built for this was huge. It was one CPP file, 10,000 lines of code. And it was a massive undertaking for me to get this to work, and there were multiple modules and everything like that. Once I started teaching at South, I started to think about, how can I use this software to actually, help other people. And so I started on the Jagsat program here. So in the Jagsat program, we're doing what is that called? We're doing a 2U CubeSat, and it's actually getting launched this year, which is very exciting. It took a couple years to get everything working, but we're on our way. And so I built this simulation, and so I went back to my simulation from grad school and basically added a texture for the world. And you can see in here, it's really crude. This is January 2016. The world is upside down, it's a cube, and then the satellite is a portal cube. But I had all the bells and whistles in there to program magnetorquers and slow this down. I decided to go back and, over the summer, I augmented that OpenGL simulation and put in an aircraft model in there. Then from there, a lot of people say simulations or all simulations are wrong and some are useful. And so I was trying to figure out, like, how can this be useful? I um, so I created this simulation here, which on the left you can see Arduino code, and on the right you can see processing. So I was trying to move towards more of like a hardware in the loop simulation, where you had flight control software running on hardware, in this case the Arduino, and then on the right was processing. And I'm not entirely sure why. Well, I think I know why. I use these two languages because they were familiar to me. And again, this is sort of what I'm getting at this video, is that doing something new is hard. And so, this is June 2016, so this is 2 years into my career as a professor. And so I had learned how to use an Arduino. I didn't actually know how to use an Arduino until I got to South Alabama. And then processing was a new program that I learned how to use, and here is a cube being rendered. And so I was able to write a 6DOF simulation in processing, and then send the state history to the Arduino to run the control algorithm, and have the control algorithm on the Arduino send signals back. And so that was my first sort of foray into serial communication. Over here in this video, I think this started on autoplay, so let me go back. Yeah, in this simulation was when I finally took the processing algorithm and I used my 6DOF simulation C++ and wrote a serial library for C++ to communicate with the Arduino. So again, I was doing hardware in the loop simulation with the Arduino and the C++ routine rather than processing. And just recently, I was able to connect all of this with my OpenGL simulation, but I'm not quite done yet, because the problem is that halfway through this, so this is October 2nd, 2020, in March of 2019, so again, these videos are a little bit out of order, is I started writing flight control software for drones. And that was a massive undertaking that, again, was very new, and I kind of just ran through it, full speed ahead, and just said, like, we're going to get this to work. And me and my senior design team, like, we just kind of hashed code together. And just like when I was in grad school, I mean, we had one code that was a CPP file that was just like 10,000 lines of code, and it wasn't that quite that good. Or long in that sense. There were a lot of different multiple modules, but I was learning about classes and modules and systems, and all of that was kind of coming together, but not really. And at the time, here's all of my repos. Let me see if I can go to just my repos here. I was starting to run into an issue where I had my C++ repo with a bunch of C++ stuff. Then I just recently launched my aerospace repo. I have a Python repo, and this is only on GitHub. I have a GitLab a set of repositories as well that has like all of my private repos. And so, organizing all of that kind of just like haphazardly happened. And, I was talking with a colleague of mine, and he works in the systems engineering department. And, he was really saying, you can't just go in on these big pieces of software and just hash it together. And so I've always had this dream to take all of the software that I've made over the years, the Blender, the OpenGL, the 6DoF simulation, the flight control software, and make this sort of meta software that can do everything. And I've been sitting on this video forever, and it's kind of ironic that I'm doing it on the first of the year 2022, new beginnings. Because the fact is that you see me on YouTube making videos, and it looks like I'm doing it. It's a really easy thing to do, and quite frankly, it's really not. I've just done it so many times that it looks easy. Whenever I try to do something new, and in this case, systems engineering and model-based systems engineering and block diagram definitions, and all of that prep work that goes into designing software is something that I've never done before. Software architecture. And, I pulled out a notebook, and, this doesn't have anything to do with code. And I started looking at I started calling it like FastSim, and I was like, okay, you need dynamics, and you need user input. You've got OpenGL, the data logger. And I didn't like the way it worked, so I tried again. I didn't like that. I tried again. I didn't like that. And then I was like, okay, let's take a step back. Let's write down all of the functionality, the use cases. What are the use cases of the software? Like, what do I want the software to do? And then, I have a control block diagram. So I was like, okay, let me make a control block diagram with some flow. But again, this is really, in systems engineering talk, this is an internal block diagram. And so I sort of hashed this together. And then I started looking at like, even subsystems of systems. So like, you've got the dynamics block in the entire simulation, but that in and of itself has its own internal block diagram. And so I started putting together and hash it out, and I still didn't really like it. I've got, I was looking at like the control system, like inner loop, outer loop, and this is the kind of stuff that I don't really show on my YouTube videos, is that all of this prep work that goes into it. And I thought, it would be really beneficial. I mean, maybe not. Maybe this video is totally pointless, but maybe if you're watching this and you're listening, maybe this has a point. Maybe I can get through to you that if you're making big software, or even if you're making small software, a lot of times it's a good idea to go through and say, hey, you know what do you want the software to look like? And as of right now, I think this is how I want the software to look. I want some helper functions, a control system, a hardware block that deals with data logging, all the aircraft controls, a UART communication for serial and telemetry, an entire sensor block, and then I want a modeling block over here in the upper right where that can get turned off if I don't need it. Again, I want software that can run on a computer, run in software in the loop mode, run on a Raspberry Pi, run on an Arduino. I want hardware in the loop, and so I want software that's modular. And I tried so many years to just throw all of my programming skills at it, and I couldn't do it. And I think that's why it took me so long to make this video, is because this is what I struggle with, this something new. Like, I wanted to just brute force it, and I finally hit a wall in my career where I couldn't do it, and I had to make this diagram. And so I put together these block diagram definitions, and I even, let me see if I can go to a different page. I even went to, to the lengths to, again, look at all the use cases, but then draw internal block diagrams. So I've got internal block diagrams here with ports and messages transferring. And this all looks kind of good on paper, but it's kind of nasty. And that's where SysML comes in. So I have a program called Asta SysML. And in the next video, I'm going to take my block diagram definition and my... Ooh, I forgot to change the theme. It's fine, no matter. I'm just going to talk here for a minute. So I'm going to take my block diagram definition and my internal block diagram, and I'm going to create these, let's find the good one. I'm going to create these diagrams in SysML so that I can finally change the software. So there's also another point that I need to make. All of my repos, I'm going to change them all because they're not in the organization that I want. And so if you're watching one of my older YouTube videos and you click a link and it doesn't exist, just shoot me an email, because all of my repos are changing. And hopefully, now that I've done my prep work and I've done my homework and I've created this block diagram definition, I have hopefully anticipated every future change of the software, and I will never have to change it. Now, I'm saying hope because, you know, that might not happen, but I'm hoping that this will be like sort of the holy grail, my magnum opus, or my, you know, my quintessential, my cream on the crop, my Everest of code here. And everybody will be able to use this. I'm going to make it completely open source so you guys can take it and run with it. And hopefully I'll be done with it in the next couple of weeks. What I'll probably do is I'll post a video on how to download and run the software. And so the next video that I post after this will be on making the SysML diagrams. And then I'm going to go into my cave and change the software to make it look like this, because the software doesn't look like this. That was another thing that I ran into, is that I made this diagram and I realized that the current iteration of the software doesn't look like this at all. And had I done this, I would have saved a bunch of time. I basically have to go rip up my current software and put it all back together. I need to break everything. And my students are kind of annoyed at it because they're just like, stop breaking things. Like, it works, but it doesn't work the way I want. And it doesn't have all the functionality I want because I didn't do all the homework in the beginning. And so I encourage you, if you are undertaking big software or even small software, draw a little block diagram. Think about all the different modules that you want. Think about all the information transfer that you want back and forth before you start coding it. The videos I create where I just code off the cuff, I've been doing it for so long, it comes easy. But in this case, I finally hit my limit, and I tried to create software that was too complicated. And so I've got to go back to the drawing board, and I did. And now I'm going to make a SysML diagram for it using Asta. And then I'm going to break the software and make it look like this diagram. And hopefully that will be it. That'll be the last time. And so hopefully, if you're still watching this video at this point, you enjoyed this. If you have any comments, you know, post below. And I hope you have a good 2022. Here's to finally finishing this software. And I'll see you in the next video.